one. All right, so my first step here is going to be distribute that -8 to both of these. -8 and 2x give me the -16x. -8 and -5 give me +40. And then I have that 3x there. On the other side, distribute your 4. We have 4x, and then 4 times 7, and then -107. All right. Combine your like terms on each side. I have a -16 and a +3. So that's -13. Over here, I have a 4x all by itself, a +28 and a -107. You are going to subtract and then keep it a negative. So I think you're going to get, what, 79 there? All right, and then we're going to move our variables to one side and our numbers to the other. You can actually move either direction here, but to avoid positives and negatives as much as possible, I would actually probably move that 13 over, because then I'm adding positives. And the same thing happens if I move my 79 over, I'm adding positives. If you did it the other way, you would just get negative and negative, and it's fine. I mean, it still works out, but that's just how I would do it. This is going to add up to 119 and 17. And 17, if you divide it out, you're going to get 7. 119 divided by 17 is 7.
Oh, okay.
So, applying equations. So, solving equations is not really the problem, hopefully. Solving equations is something you've been doing, solving for x. Now we're actually going to see, when am I going to use this, or at least when am I going to use this in this chapter and for this test, and this is when you're going to use it. This is going to be the step to solving a problem, whether you are in math class or whether you are in a science class, or whether you are just in life and you're trying to figure out a problem, really. Understand the problem. So you have to read the problem and know what you're actually looking for, okay? It's really great if you solve for time, unless I wasn't asking for time, right? Then we have an issue. So always read the problem carefully. You've got to understand, is this important? Is this not important? Oftentimes they will give you information you don't necessarily need to solve the problem. And so you have to understand, this is extra information. I don't need it. Put that to the side. Or this is information I'm going to use, just maybe not necessarily right now. Or this is pertinent to what I'm about to do. I need this information. So make sure you read the problem, know what you're actually solving for, and know what's important and what's not important. Key phrases are important too. Sum, quotient, like those are key things. They left earlier, they left after, things like that are giving you key information that they're not necessarily saying subtract or add, but they are giving you keywords that indicate you're probably going to need to do something with it. Represent unknown quantities algebraically. That's just a fancy way of saying give each thing you don't know a variable, right? Oftentimes in word problems, I would actually recommend that you use a variable that represents it, unless it's something that's going to confuse you. I do use a T for time, but I make sure I write my T in a way that it does not look like a plus sign, okay? All right, this is why I don't use an X for multiplication, because very often I use an X in my variables. I never use an O. Why do you think I don't use an O? Looks like a 0, and that will cause me major issues if I have 3O, and I think it's actually 30, but it's really 3 times some variable, right? So I don't use ones that look like something. Be careful with Z. I use Z, but I actually write a line through my Z, because very often Z will look like a 2. So when you're assigning these variables, 2 things. One, you want to write a note what it stands for, because I cannot read your mind, right? Not necessarily a bad thing, but I can't read your mind for most of you, and I would say you need to tell me what variable represents what. This is also because you may start at the top and say, in your brain, say X represents this, Y represents this, and you get to the bottom and you don't even remember, and maybe you solve for the wrong one. So always label your variables when you assign them. Once you have done that, you have to figure out what you're going to do to solve this guy. I'm going to show you many methods, right? Sometimes I'll say draw a picture. Sometimes I will say draw a chart, right? I'm not just telling you this because I want to see your artwork. I am telling you this because this is going to help you visually understand what you're looking for and how you need to solve it, okay? So plan a way to organize and label your information. Then you're going to solve the problem. So once you've set up variables, laid it all out, then hopefully you should have some type of equation that you can come from this. And at this point, you're just solving the equation like we just did in this last section. You have variables, you're solving for said variable, right? And that's just basic algebra number crunching. Once you've done that, check and see, is this reasonable? This is a very important question. I use this example every year. When I first started teaching, I gave a word problem. It was trying to find the speed of a boat. They gave me something like 400 miles an hour. And I was like, have you ever been in a boat? And they're like, sure. I'm like, were you airborne? Because 400 miles in a boat does not bode well for staying on the water. That's not a reasonable answer for traveling in a boat. If I were in an airplane, maybe we'd have a different conversation. So make sure it's reasonable. If I ask for time and you give me negative 3.2, I'm going to ask you how you're time traveling. Why are we going backwards in time? Time should most likely be positive. And so when you get to these answers, somewhere in your brain should be like, this does not make sense, right? All right, so if I'm asking for how many people and you give me a decimal, we also might have a problem. We have a partial person, right? So your answer should make sense. And when I give you a problem, I'm never going to give you an answer that's not logical to the problem, okay? So always ask, is this reasonable? Does this make sense? If I were just to predict what would happen, does this make sense, right? And that's what you're going to do to check it. And of course, without the algebraic piece, you can always plug it back in. Now, if you set up your problem wrong, you might get the right answer anyway. But so always make sure, does it make sense? And you're always going to follow these steps. Read the problem, make a plan, solve the problem. Does it make sense? All right. So let's look at some examples. The footprint of the Lincoln Memorial is a rectangle. Determine the memorial's dimensions and area if its perimeter is 620 feet and its length to width ratio is 19:12. Okay. So there's some keywords here. The first keyword, if I were reading this problem, would probably be the word rectangle. All right. Why? Well, they're asking about area and they're talking about dimensions, right? So chances are good I probably want to sketch a rectangle, but that's a keyword. What am I looking for? Well, other keywords here when I'm reading this problem is that I'm going to be looking for the dimensions, how long and how tall it is, or how wide and length and width, right? And the area. Area of a rectangle is just length times width. So when I find the dimensions, then I also need to find the area. It's important that you note that because you may find the dimensions and then box those in and move on to the next problem and you didn't answer the entire question. The question also asks for area, right? And then they've given me some information I probably am going to use. They've given me what the perimeter is, and they've told me a ratio, meaning if I were to multiply 19 and 12 by the same number, then I would get the length and width because they are in the same ratio. All right, so that's what ratio means. Anytime they ask ratio, say the word ratio, they're saying you can multiply every one of those numbers by the same number and you'll get the length and width or whatever it is. So for this one, my plan then is to draw a rectangle. I'm going to sketch a rectangle for this, all right? And so the first thing I'm going to do is I'm going to draw a rectangle. Once I draw the rectangle, it's saying the length to width ratio is 19:12. Now, it did not tell me that the length and width is 19 and 12, right? It told me the ratio is, which means I need to multiply 19 and 12 by the same said number, but I don't know what that number is, right? And so I'm going to say that x is going to represent the ratio that I multiply those by, ratio multiplied. I'm just going to make a note there. That's what that is, okay? That's not the length. That's not the width. That's just what I'm multiplying those by, all right? So now I have something for my length and something for my width. They told me the perimeter, all right? So it's probably important that I know how to find the perimeter. How do I find the perimeter of a rectangle or anything? Yeah, just add up all the sides, right? This is the distance around, all right? So if I added up all these sides, I would have two of these, right? Two of those. So I'm going to scoot him over a little bit. If I were to find my perimeter, I would say I'm going to have two of my widths and I'm going to have two of my lengths. Or you could say 12x plus 12x plus 19x plus 19x, right? And then they told me what that is. What is my perimeter? 620. It helps to write it correctly. So 620. All right. So now I have an equation. And when I solve this equation, I will be solving for x. That's why it's important to know what x is. I'm nowhere near done when I solve for x, all right? I have a couple more steps. But I do have an equation and a way to figure out what x is. So at this point, I'm already at the solving, all right? So I'm going to say 2 times 12 That's 24x plus 2 times 19. That's 38x equals 620. I'm going to combine these guys, 24 and 38. And they were very nice to me, weren't they? X equals 10. All right, x equals 10. Now, this is going to help me find my dimensions, right? Because if I know that my width is 12 times x, and I know what x is, how do I find my width? Just multiply. My width is going to be what? 12 times 10, 120, right? Does everybody agree? What are my units? Inches, yards, feet, miles. There we go, it's feet. And my length is going to be how long? 19 times 10, right? 190 feet. I have answered part of this question. This is part of my answer right here. All right? Part of my answer is my dimensions, all right? Or are my dimensions, rather. What else do I need to do? Area. What's the area of a rectangle? These aren't hard area problems, right? It's just length times width, right? I already know what those are, so I'm going to say 120 times 190, and I'm going to hope they did that for me. 22,800. What are my units here? What's my units? Feet squared, 2 dimensions. Good job. All right. Now, does this make sense? Well, my dimensions are in a ratio, 22,800 square feet. It's a big old base, but if you've ever seen the Lincoln Memorial, you would know that's a pretty big item to be calculating. So yeah, everything makes sense, and I have answered the questions. Determine dimensions and area. I have answered both of those. So we have distance, rate, and time. Remember, distance equals your rate times your time. All right, if I'm going 60 miles an hour for 2 hours, my distance is 120 miles, right? Distance equals how fast I'm going, how long I'm going that fast. We have different types of distance problems. We have round trip or catching up with someone, okay? So round trip, if I go there and come back, my distance is the same. If 2 people start at the same distance and one of them catches up, or start at 2 points and one catches up, their distance will be the same because they started and caught up at the same point, even if they did it in different times. Opposite direction. There's two different types of opposite direction. One is they start opposite and they head toward each other. The other one is they start at the same point and head away from each other. Either way, you add these up, all right? Because you're taking both of their distances and they add up to their total overall distance, whether they start far apart and meet or whether they start some in the middle and go out, all right? Different distances, which we won't do a lot of these. We'll do mostly these two types right here. With different distances, usually you have one total distance equals the other person's difference and the difference between them, which is why you have this one distance equals some distance 1 plus the difference between the two. All right, let's look at these examples. All right, so example 2 in your book, it says, Ted and Jeff planned to leave for church at 9 a.m. to go camping, but Jeff was delayed until 9:30 by driving an average of 8 miles an hour faster than Ted. Jeff arrived at the campground at noon, the same time as Ted. What was the average rate of speed for both Ted and Jeff? All right, so when I set up these, I set up a chart much like this. I am going to label my chart based on the information. So for this case, I have two people. So I am going to label this with the two people because I want to keep up with what's going on. Then I have their rates and their times. And I know that if I take their rate and multiply it by their time, I should get their distance. All right? So that's what I'm going to do. I'm going to say, what do I know as a fact? Well, the one thing that they told me clearly was time. Why did they tell me their time clearly? Well, I know that they both planned on leaving at 9 a.m., but Jeff was delayed. So I know that Ted left at 9 a.m., and I know that Jeff left at 9:30. I also know they both arrived at noon. So if Ted left at 9 and arrived at noon, I know how long he traveled. How long did Ted travel if he left at 9 and arrived at noon? From 9 to noon. How many hours did he travel? 3, right? Ted traveled 3 hours, right? He left at 9. He arrived at noon, right? 10, 11, 12, 3 hours, all right? Now, Jeff left half an hour later. So he traveled 30 minutes less time, right? But we're talking hours. So how long did Jeff travel? 9:30 to noon. Half an hour later, 2.5 hours. So we're going to say 2.5. You can say 5 halves. I don't care. As long as you represent it either decimal or fraction. It depends on what you like. Do you like decimals? Do you like fractions? Either one's fine. All right? So I know those as a fact. So then I'm going to say, what do I not know? Well, I don't know how fast they were going, do I? It does not give me the rate. So I am going to say that rate is going to be represented by the letter R. All right? Do I know how fast Ted was traveling? I do not, right? Do I know how fast Jeff was traveling? I do not, but they did tell me something about Jeff, didn't they? He was going 8 miles an hour faster than Ted. So if I were to take Ted's rate, what would I do to it to figure out Jeff's rate? I would add that 8 miles an hour, right? So if I'm going 50 miles an hour and Lewis is going 8 miles an hour faster than me, how fast is Lewis going? 58, right? That's what that means. So I'm just going to take Ted's, which I don't actually know, and I'm going to write it as a variable, but I'm going to say plus 8 for Jeff, right? Well, how do I find their distance? Well, to find their distance, I multiply across. So I'm going to take this and I am going to multiply across. R times 3. The way you write that algebraically is 3R, right? 2.5 times R plus 8. 2.5 times, anytime you have a plus minus, you want to put parentheses, R plus 8. All right, R plus 8. Now, what do I know about their distances? Well, they both left church. They both went to the same campground. It doesn't matter how long it took them. What do I know about their distances? They are the same. And our rule says that if anything's the same, you can just set it equal to each other, right? That's substitution. If this equals this, I can just say it's equal, and I can actually write it out that way. So I know that Ted's distance, which is 3r, and Jeff's distance, which is 2.5r plus 8, is the same distance. Why are you just not scooting up for me? There we go. All right. So I'm going to write that out. I'm going to say, well, 3r must equal 2.5r plus 8. All right. So far, so good. And that's what I'm going to do. I'm going to solve it. So 3r, he's already by himself. Leave him alone. 2.5, distribute him through. 2.5r plus 2.5 times 8 should be what, 20? 16 plus 4, right? All right. What do I do now? Well, I'll get my variables to one side. Subtract that 2.5r. 3 minus 2.5 is 0.5. This is why I like to do fractions. I'm going to show you in a second. Divide by 0.5, you're actually going to get 40, right? Everybody agree? If you divide 20 by 1/2, it's multiplying by the reciprocal, which is multiplying by 2, right? That's why I like to use fractions. But if I divide both sides by 0.5, 20 divided by 0.5 is 40. All right. What did I solve for? The rate. Specifically, whose rate? Ted's rate. So I know that Ted was going 40 and they were going miles per hour, right? Why do I know that? Because I know this right here. They gave it to me there. If he was going 40 miles an hour, how fast was Jeff going? 48 miles an hour. So then I want to make sure, did I answer the question? Average rate of speed for both Ted and Jeff. Yes, I did, right? Does it make sense? Well, 40 miles an hour for 3 hours. I could multiply this out, right? 120 miles, right? 2.5 times 48. Does that multiply out to 120? So you can figure it out, right? That you did this correctly by just multiplying. Do their distances equal the same thing if I multiply 3 hours times 40 miles an hour and 2.5 hours times 48 miles an hour? All right. If I had gotten that Jeff was going, 150 miles an hour, maybe we question, or that Ted was going that fast, maybe we question if I did this right. Okay? Does that make sense? So you're going to go through that whole process. And in this case, I would draw a chart. So let's try one of these.